Who had a good time so far? Good? I will do my very best to keep it this way. So, thank you for coming. I know it's late. And thank you for being here and not at the beach, which is always an option here, right?
Instead of 3 weeks.
Now, let's do a quick test so I get a little bit of an understanding of the audience. Who has done dependency injection before? Okay. Who has done dependency injection in depth before? Okay. Who feels comfortable with microservices? Who uses microservices? So the nature of the talk is to go and show how you define boundaries in the code you write and the application you design. The way having 60 minutes, I design my talks is to make you hungry for more and know where to start. To give you things to look into as starting points, but rather setting you on the journey than sending you to the finish line, just to give you a little bit of an expectation on what you get. I'm a little bit limited because I switched my laptop in the last 2 hours because I have a broken display, so it does not everything work yet as I would like, but I have enough to do the session, and I think we will have a good time, okay? With this said, I think it's time to get started, so everyone gets to the evening afterwards on time. I'm Theo Jungeblut. I work with AppDynamics. I actually moved over to the dark side as I wasn't careful a couple of years back. I'm a manager, right? So I'm actually, in fact, what I would call dangerous because I know enough architecture and have done this in the past, but I do focus more on managing bigger teams these days. So in some regards, it's the people where I would say, they know it, but do they know it still well enough? Well, you can judge afterwards, okay? I've worked in different industries. I've done factory automation, in-house consulting. I've done healthcare. These days, I work on application performance management, application intelligence, helping customers to put it in use and enabling them to be more successful in their production environments. The slides are on SlideShare. At least older versions. I will update these as I did a good amount of changes later on. And this time I really do. So you can take pictures, but you can also just download them as you like. You're welcome to ask questions. I'd much rather have a good conversation and share the insights of people as we have people who have done what I'm presenting on before, than just standing here and talk. I can do that. And if you really, really want to be out fast here, I speak twice as fast. I just switched to German, and we are done by 4:30. It's your choice. Having that said, I always remember Germans are always serious, they're never fun, and never tell jokes. So what I want to do is look into the issue and why I think clean code is a subject and why decoupling has to do with it. I want to go into dependency injection, but I want to touch it to a certain amount. And based on how much you know it, I can go faster or less fast. We figure it out. And then go, what does it give us in regards to decoupling? Where does it help? Where does it stop? What do I do next? And what is really the evolution of decoupling further and further for what benefit? So, what is the problem? What made you show up at 5 on a Saturday instead of the beach with a cocktail in a beautiful conference room with me, right? So I assume, let's make the test. Who's writing software for 1 year or more? Raise your arms. 3, 5, 7, 10, 15, 20. We have a lot of experience in the rooms. So there must be something to it, while I have done it for so many years, to make you still be hungry for more and to look for some answers, right? So we're an engineering, a group of engineers, right? So engineers have ways to determine if they did a good job or a bad job, right? So how do you validate if you did a good job with the code you wrote or the architecture you did, the implementation resulting into the product? What's the unit of successful implementation? How do you measure code quality? Anyone? Do we have a measure of...
In production, I suppose.
It works in production. So
It doesn't hopefully blow up.
days without pager duty or on-call calls to do emergency fixes in production, is that the unit of success?
No.
So the best I found if it comes to code quality was this, right? As you can see, the world is black and white, as I am black and white, almost. So it is about WTFs. Anyone below 21 in the room? Okay. So you do a code review. And the question is, how many oh my gods do you find in your code base doing that, right? Or WTFs, whatever works better for you. Now, I think there's something true in this, right? Because you have something where it seems there's a problem, right? There's a lot of these. But on the other side, there's still some, right? Which tells you also one thing. It's not about being perfect, but to be better and better, or hopefully to be good enough to do it successful. Now, who's doing code reviews on a regular basis? Okay, lift your arm, and now let's try this. Who's doing code reviews and who's reviewing the code before going into the room, having ideally reviewed the code offline, provided the comments to the person of getting the review, that person had chances, and then you discuss about the open questions. Who's doing something like that? That's productive, right? Because if you go in the room and just review the code and in that moment start reading it, are you really successful as a team? Just think about it. Now, what is clean code? Because I coupled two things which for me belong together, which is clean code, and one subject of it is decoupling together in one talk, which either means I'm really good in writing titles and interesting session descriptions which made you come together, or there is a reason for it why I did that, right? So anyone wants to try and say, share what the definition of clean code is?
Code that is easy to maintain.
Code that is easy to maintain. Okay?
You have a new hire, and you have to spend only 5 minutes or 10 minutes, then he looks at the code to understand what you are doing.
Okay.
Easy to test.
Okay. Easy to test. Simple. Cool. So we don't look for the most complicated solution, right? Artfully crafted, 10 statements combined in one line of code. Maybe. Anyone's guilty of doing that in the past? Anyone ever optimized on how much code you can write in a day? Come on, be honest. We all started at some point, right? And we all did that. So as many said, there's not one definition, and I share two. This is mine, which is code is maintainable. And code is maintainable means it is readable and well-structured because it has the parts to it. Yes, writing lines of code is important, but the fact is we read a lot more code than we write. And you read to understand, right? Someone in the back said, hey, how easily can I understand it? Who's debugging? Anyone is debugging? If you debug, do you read or do you write? Does it help as you read the code to have code which is good to follow? Anyone ever managed to write code which the debugger doesn't show you what happens anymore because you combine so many things that it doesn't give the output? I'm guilty of this. This is why it's for me fun to speak about that. Who is maintaining code which has never released to a customer, brand new code base, never released, written from scratch? Who's working on this? You're the lucky ones, right? Everyone else works on legacy code, right? So you need to extend something which is there, which is in production, which you need to make sure while you add something and while you maybe fix something in the code base, a bug, you don't break something else, right? So whatever you do should not have side effects. And to get there, code should be testable, right? Anyone ever try to write automation tests for a legacy code base afterwards? So lift your arms, and now we want to lift them high. And now the person who managed to succeed on really implementing, then leave the arms up. There's a reason for that, right? Because it's like adding something functionally across the code base afterwards. Like adding security afterwards into your code. You build it in, or you do a lot of work and a lot of hard work to add it afterwards. And most time you fail. Now, coming back to the subject of decoupling and a different overview, I took this from a presentation Mark Seaman did a couple of years back for actually our user group here in the Bay Area. He spoke about code maintainability, about applying principles, patterns, and using containers, as it was in the context of dependency injection. You're asking the right questions, the why, the how, and what. And also making clear that things should be extensible, we should do clean code, and we should do tool reuse. And tool reuse is for me two things. You use tools which make your life easier. Anyone writing with Notepad? Only with Notepad? And there are people who do prefer that. Typically not Notepad, but I picked this for a reason. But there are tools which make your life easier, right? And there are libraries which make your life easier. Utilize them. Don't do everything yourself. We engineers have the tendency to do that, right? Anyone ever said, oh, this library for doing dependency injection, this container, it's out there, 1 or 2 or 10 or 15 or 20, right? But there's just this one feature we need in our implementation. For that reason, I need to write my own one. Ever heard or seen something like that? It's a little bit like architecture by resume, right? Because you architect something where you think the technology or what you have accomplished you can put later on in your resume. It's not beneficial for the company. Use existing libraries as they are appropriate. Now, coming to decoupling. And in order to decouple, then must be something which is tightly coupled, right? So let's look a little bit on code. And I kept the code in the presentation because my switching doesn't work. It is C# code, but it doesn't matter, right? It's very simple code. I have a class. The class uses an external object. In the constructor, I create the object, right? The logger. I create it, and I use this. If I now go and say, let's see, how many money do I have in my wallet? 1, 2, 3, 4, way too much. I give you $100, 20 minutes. You write me a pure unit test to write this class following a pure unit test approach, testing if whatever I do here, which I didn't specify, is working. Do something, it doesn't matter. Anyone is taking the challenge? Where's nobody taking the challenge? Where's the tight coupling? In the constructor. What precisely? Yeah, so, okay. What we learn is because here I basically say create the object. The first coupling is a managed lifetime, right? The second one, I need to know what the logger is. Now, if I go and the best way to see new is to say it's glue, right? Because in the moment where you call new and create the instance in your code, you're tightly coupled and you don't get around this. And yes, there are tools around there which allow you to effectively mock something out which is statically compiled in, but that makes it really complicated. Anyone uses such a tool? That's the reason why, right? Now, with dependency injection, we do something different, right? So let's look into this. I changed my code. Now I pass in an object of type logger. I don't create it anymore. I assign it here to a private field, and I use this. Do I do the dependency injection? It's constructor injection, right? Am I decoupled? Yes? No? Who says no? Anyone wants to try it? Yeah. So I decoupled the lifetime management because I get the object from somewhere and someone else is handling now the lifetime. It's not in my control. But I didn't decouple the implementation, right? Because we didn't specify what kind of decoupling we're talking about. So if I go and make a small little change, now I used an interface. It's a concept which is in C#, in Java, some other languages. You could use an abstract class. It has the same functionality. So let's use an abstractation, right? So instead of defining how a log is implemented, I pass in an abstractation. I use an abstractation. The abstractation is defined in a neutral place, and I'll talk about this in a moment. This is why my namespace statement comes on top. And now, effectively, I still have the same code, right? Beautiful. I spent hours writing this. This was really, really difficult. If I now give you $5, 5 minutes, anyone takes the challenge? Why not? Too late? You could, right? Because this is something you could test, right? Because if you would write and the pure meaning of unit tests, and don't get hung up on this, is you test something without dependency to other code. Now, if we take this to the extreme, I said new is glue, don't use dependencies. Now, we don't use new ever again in the code base, right? Everything we abstract, right? Anyone ever try to abstract the string class? There's a reason for that, right? And we'll come to it. But this one you can test, right? Because if you would test it, you write a unit test where you say, I put in what I put in on top of here, saying there's a definition for my abstractation. That's okay. There's no real implementation. I mock the logger with just an object in my test which satisfies the public contract, which is, in this case, the interface for the class and the constructor. And I use this to test my code. You could earn the money, right? This is why I put my money into my wallet quickly again. Now, why? Yes?
So in your current code base, tell me honestly, do you inject every logger in the current whatever you're working on?
Oh, absolutely not. And I come to this in a second. Give me 2 minutes and I get there. Now, the benefits of dependency injections, and one I have not shown, is late binding, right? So everyone knows what late binding is? Yes? Anyone does not know? Should I just explain it? Late binding means at the compilation time, I do not need to define what the implementation is. And that can be beneficial if I want to replace something which is used. That's, for example, your logging framework, which you never should implement, but you would implement it, and you would basically specify where you write the information to. And you would want the ability to change this and even add something which is not compiled in at that point of time. Late binding would allow you to do this. So dependency injection would mean you would include by configuration into your code at the startup that it gets read what should be used when, in this case, we used for the iLogger interface and implementation is needed. Then through the configuration, this gets read, loaded, and then used in the implementation. That's late binding, allowing you to do this. Compiling decoupling, right? You decouple from being tightly coupled at compile time. By the way, if you have the chance, rather do configuration in code, because then you have compile checking, which is really, really beneficial to avoid a lot of configuration file debugging. Now, extensibility, I think I made the point just now, right? Because you can change something, the implementation. In the extreme case, even at startup time, in the normal case, even where I bootstrap the whole thing, and I come to this a little bit later on, who works in teams? Or the other way around, anyone maintaining their own code base just working by themselves? You guys still do exist, right? But you are getting less, right? We're working in teams. Working in teams means typically you have one team who needs to implement a piece of code, be it a service, be it a component, or whatever your abstraction level is. And you have another team, most likely, who needs to implement where it gets consumed, right? The piece of code which you use it in. How can you develop in parallel if you don't decouple? Because if you have a defined boundary and a defined contract on how this piece of code, right, be it a class, be it a component, be it a service, how you engage with it, right? How do you call it? What do you expect? If you define this, one part of your team can basically mock out the implementation and just say, based on the definition, I know it will have this contract and it will behave this way, and I have a test harness to test against it. Where the other team can say, I implement this and write basically unit tests and functional tests for this component to make sure that based on the definition of the public contract of this component, it works. Now we can walk more or less in lockstep, right? Otherwise you wait. Do you managers like to wait? I'm a manager, right? So I know we don't like to wait. We want you to do these things in parallel. Testability, I think I made my point, right? I put my wallet back and we don't need to speak more about it. Now, what we did do static dependencies. We decoupled the dependencies. I explained a little bit about classes, component dependencies, and with teams, right? So we did decouple code, components, and team dependencies in that regards. Are we done? Right? These four things. Now, I didn't explain what a dependency is, and now I come back to the question from the back, right? Because obviously, you don't want to decouple everything, and you don't want to use dependency injection for everything. Your code would become totally unusable. I think everyone who has used a little bit dependency injection will agree. If you would try to resolve everything, the code is not getting more maintainable, it gets less maintainable. So we need to differentiate between stable dependencies and volatile dependencies. So stable is something which you really can assume it will not change, probably not tomorrow, not next year, and not in 5 years. Anyone using .NET or Java as an example? You probably don't try to do a dependency injection for core framework classes and components, right? Because, at least on the class level, because you can consider them being part of the foundation of the programming platform you're using and language as stable. String is the extreme example, but there are many other variations to that. Now, what you want to decouple and where you want to use dependency injections are volatile, right? Something which could change or has a dependency like, for example, to your team. So anything which has the tendency that it will change over time could be replaced. You have some worries about it. And this can even be a third-party library in that regards. Anyone ever ripped out a logging framework, ripping out one and putting in the other? My first company made us do it because they didn't like the open source. It's a long time ago. We all love open source now. But version and put in the one which then came with the platform. If you decouple correctly, it took a morning plus testing. Now, DI. Dependency injection was coined by Martin Fowler, right? I don't know, 15 years back or so. And his focus was on object composition and object lifetime management. And Mark Seaman, in his book on dependency injection, goes one step further and also includes interception, which for me makes a lot of sense. I will not speak about it, but it's a good subject to look into to see where you can take advantage also, or to making your code more decoupled for certain aspects in certain scenarios. Now container, right? For the people who use dependency injection, anyone is using dependency injection without a dependency injection container? Anyone ever has tried that? Because if you use something, you create a dependency again, right? At some level. It's understanding where you create it. Obviously, it would not be a good thing, because like with everything in life, you try to take one pain, decoupling, or the tight coupling, and solve it, and you introduce a new pain or a new thing you need to solve, which is how do I resolve my dependencies, right? Because I need to, at some point, there needs to be a piece of code responsible for saying, create this object, which represents this abstraction, this interface abstract class, and provide it to the piece of code which needs it, right? And I did show in my previous example, as I said, don't do the logging, constructor injection. If you're unsure, constructor injection is your best friend, because it's the most common way. And the good thing about constructor injection is, and maybe for that I should go one time back to here. It's something I didn't do here, which I should have done, right? Because constructor injection is the only dependency injection way which allows you to fail fast. Everyone aware of the concept of failing fast? Failing fast means if something does not work, and if the error would result into a not usable system, the error should happen as fast as possible and be exposed as early on, because it helps you to avoid a lot of troubleshooting, right? So the correct thing I should have done here is check if I really got what I needed, because that would allow you, if you look into a class, for example, if you need to implement something or understand something or test something, to say, okay, what are the dependencies? With constructor injection, they come in the constructor. I can test them at creation time of the object and just throw an exception otherwise, and understand what's needed. It sounds so minor, right? The reason why you should do it, anyone has used the service locator approach? Do you know what the service locator is? It's a great component. Most platforms offer it. It's something which is static, so I can say, if I have it in my code base, something like service locator dot give me the world. It's awesome, right? I have a little thing, magic. It gives me everything. Anyone ever had problems with that? So I worked on a product where I was supposed to write a test for. It was not my code base. I brought in this class. I looked into what dependencies do I see, build it up, compile, fail. To make the long story short, I did this for a few hours. Eventually, I started in the morning. I went home in the evening. I always brought in more dependencies because they use the service locator everywhere throughout the code base. So you would need to read the whole code of this class or component. Every other component it was getting via dependency injection. So I went home, didn't accomplish anything, slept, came home, fresh, helps, right? Had a good idea, spent 15 minutes, compiled, yes, run, yes, awesome, problem solved. What did I do? I went into the actual application, got the whole code bootstrapping for all components, the whole application, plus the configuration getting everything. So I brought everything into my little test. It was huge, but it compiled and executed. This is why service locator, in a very practical explanation, can be really your enemy because it can make your code unmaintainable. Now, going back to what the container does for you is, that's where you want to spend your time. That's what you need to do, right? You need to create objects. You need to get them where you want to use them in your code. And then at some point, you need to release them, right? And there's a pattern for this, which is register, resolve, release. I would just want to point for it. But what I really want to say is, you want to do separation of concerns. This is where you make your money, right? Do we have plumbers in the room? Because the other stuff I showed you, that's plumbing, right? That doesn't add any business value. It just makes you have code which functions, right? If you want to decouple, want to use a dependency, give me the dependency, you use this, that's what you care about, something releases it again. So with dependency injection, you can do decoupling, you can focus more on the code you want to write. I will not go into the different patterns on release and so on, because we have very limited time. But there's one thing I wanted to mention. For doing the registration, there is a pattern which is called the composition root, which means at some point, if you have all these loose coupled things, right? Imagine you have 1 million pieces standing by itself. That's not an application, it's not a value, right? It needs to be some place where you need to bring them together, something which knows how to build this, how the dependencies are, where to look, and be it with XML configuration, be it with conventions for reading this in. But ideally, you create something which is a composition root. So if you have a service you bring up, it's probably there at the very beginning of the service creation. If it's an executable, it's probably where you really start the executable, but you want one place which does bring everything together, because otherwise you wouldn't have the application you need and the functionality you look for. Now, great. We have all done this, right? We have done dependencies. That's a good book to read. Are we truly decoupled? Let's see. Half an hour left, right? I told you, make it in half an hour. Are we good? Okay. It was fun with you. I go for the barbecue now. Because if you think about decoupling, right, and to visualize it, right, you have something very, very complex. You break it down into smaller pieces. I typically like to ask, I give you the pieces, 2 hours of time, $200. You build it functionally as you see it here. Look a minute, start. We are engineers, right? We are good in visualizing. Anyone take the challenge? It's the same if someone comes and says, write an ERP system or write this app, right? The system you work on are too complex. You need to break them down. You do this in logical ways, and this helps you. So we did decoupling so far with dependency injection and really look, as I said, into the static, the compiler time, the code, the component, the team complexity. Is this enough to be decoupled? Is there more? Anyone working on web scale applications? Do you run in one process? On one box? No, because first of all, we are still coupled with the platform we use, right? Because the component and everything I showed so far is all depends on the same platform. We are coupled by the process, as I just mentioned, because everything I showed so far runs in one process, which means you need to care about the resources for this process, which on different platforms is differently. We need to care about the host, right? Anyone ever was in a game of buying every year or two a bigger Mac server in order to scale with the load? Because you may have your code base decoupled, but you didn't decouple the ability to scale your application up, right? Because it was not designed for it. How do we solve that? So yeah, all this is missing, right? Who works in a DevOps team? Or who works in good friendship with the production team? And I don't mean you have the release, you rip this over, and then you run and go into the weekend. And yes, I know also a developer who said cloud offerings is the best thing ever because I really dislike the operations team. With that, I can obsolete it. I push it in the cloud, and I don't need to deal with them anymore, right? DevOps is a good thing, trust me. Now, microservices, right? What's the difference of a microservice? And a regular service, before we go into microservice, will be the in-between step, right? So anyone who has done, and SOA was a first attempt, and I think we can all agree that it kind of failed, right? Too big of a complexity. But a regular service is the first attempt, saying instead of having everything running in one process, I run things isolated in different services. They get hosted on the web server or on some kind of a hosting platform. It decouples certain aspects, right? It's not in the same process. It can have different languages, but there are still limitations. So microservices go one step further, right? Because they say one thing which, if you look into separation of concern, is about which is you should only do one thing, right? And do one thing well, but precisely do one thing. Because if you do one thing, what you have is actually maintainable. Who's running microservices with 2,000 lines of code? 200 lines of code? 100 lines of code? 5 lines? What's a good measurement on how much code you should have in a microservice? Yeah. 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 Yeah, and in your function, I would probably argue if you try to write your test. By the way, I've never been the TDD person because I write code which works, and then I apply all the principle to make it maintainable and form it out well. I try to do this from the beginning, but at the moment where I go and write the test, which I do slowly after, but way before I check the code in, by the way, and before I push it really to be part of a release. If you implement the test, it will typically show you if you have too much of a hard time to write the test, you do too many things in your function, and often in the service. And by being able to write a valid, good unit and then also integration test, it will shape the quality of the code you have created and keep it to do not too many things, right? Because code should not have side effects. It should do one thing. So if you take a microservice, it brings it to the next level, right? Because with a microservice, and assume now, who's using Docker containers for the microservices? Who's using microservices without using Docker? Okay. The majority uses Docker, right? Because it's a great way. So why is this a great way? I have an easy way to describe, this is a service, this is a piece of code I want to run. It needs this dependencies, and it needs this kind of unit of size of environment, right? Because in a Docker file, you specify how much CPU, memory, for example, right? You do? Yes. And that allows you to take this container and have something decide on where you run it, right? Because now you have basically a boundary around the resource consumption of your piece of code, of your service, with the definition of the code, with basically a protocol, how do you get to it, how to engage this in an API, in a public contract. And you have decoupling on many ways. So as we build software for production, right? Who's not using some kind of service orchestration with their microservices? Anyone is writing their own implementation for how to build this dependencies together, right? Because in the end, the microservice has the same problem than my dependency had before. How do I know where is something, what's there, and how to consume it, right? And what do we use for that? Anyone use Kubernetes? Yeah, so it doesn't describe it, no. It provides a way to easily take, for example, the Dockerized service to spin it up, host it, or put it in production, right? Because we developer implement something to get released, but actually the money is made by running the application in production and have people use it.
Yeah, Kubernetes simplifies some operations.
Yeah.
For example, history and everything, but it's not easiest to open under the microservices.
Yes, thank you. So, coming to the pain, right? Or discussion again. We solved more problems on the decoupling. We added a complexity, which is Kubernetes. Who in the room believes he's a Kubernetes specialist? It's not me, and yes, I'm a manager. But you need, suddenly, because part of what you need to do is you cross from the pure development into the production rollout, right, and the hosting. And this is where DevOps is very important and will get more important, because only if the two things come together, you work fast and efficiently. Now, technology solves everything, right? So, you correctly pointed out we have a new dependency, which is Kubernetes, or the orchestration platform. They are more than that. But I think by today, Kubernetes is more or less the de facto standard, right? But you depend on understanding it, maintaining it. So, can we decouple that too? Anyone has an idea? Can we decouple that?
Kind of.
What do you use? AWS is everything cloud from Amazon, right? But there is something specific for AWS in Azure too, right? Serverless. Anyone heard about serverless? So we go one level further, right? Instead of saying we need to maintain building Docker images, defining how we maintain them with the orchestration and put this all there, we say, hey, there's a platform which you just tell, here's a piece of code, run it for me, right? And the platform figures out where to host it, what resources to use, how to scale it. That's great, right? Do you think you've heard something like this before? A technology most of you don't think about it anymore? Ever heard about the mainframe? Think about it. A mainframe was a huge box you didn't own, which you paid for by usage, right? By CPU usage. And you run your operations on which you just provided your functions. Doesn't that sound a lot like serverless? Just serverless is doing this at scale. There's some similarities, yeah. I always want to provoke. But serverless has the ability to say, I do not need to care about the hosting infrastructure, right? And that's the next level of decoupling. Because if you want with serverless, you can take all this, and there's still some amount of management there, yes. It doesn't go precisely away. And there is a part of how this comes in production together. But it abstracts a lot of what you previously needed to do manually, for example, with Kubernetes away. Who's using serverless? Who's using exclusively serverless? Right? Because you could take this dependency, you could reduce the dependency. You cannot take it out, you can reduce it. So why don't don't we do this? This was not planned. Okay. It's this considerations, right? Who has an existing code base, right? Because serverless, you design everything against the serverless platform because you use Microsoft functions, right? Azure functions. You use AWS Lambda. It's not that you can just say, I take my existing code and run it. So that's the first limitation. Anyone works in a bank? Do they allow you to use cloud platform? They're getting there. I can tell you they're getting there, but what they do is they use private clouds hosted, isolated, or by the cloud provider. So it is coming. But it's also a concern, right? Not every company accepts every technology. Then, while you reduce dependencies, you're introducing actually a really big one, right? These functions, AWS Lambda or Azure functions, they only work on the platform, right? So while you decouple all these concerns, you are more tightly coupled in there. Which brings us to the last thing. Costs. When cloud computing came up, I saw an introduction talk, and they talked about one of the great benefits of cloud computing is the elasticity, right? You need more resources, and if your application is designed for it, you can basically tell the cloud environment, scale 1, 10, 1,000 instances up, and it does it very fast. However, it was a lot more expensive than at that point of time hosting your own server in your environment. So what did people do? A hybrid approach. They run most of their default load on existing server and had the combination by doing the load balancing and spinning up of cloud instances for the peak loads, which avoided them to have way too much hardware, which they don't use for 50, 80% of time, while not spending too much for the pay-by-use, right? Which cloud computing is. Lambda's serverless today is very similar. If you use cloud, you probably use who's using reserved instances knows what reserved instances are. Reserved instances means you go and make a contract with your cloud provider and say, I pay for the next 1, 2 years, whatever your runtime is. I think 2 years is very common. I have these amount of instances I can use. I pay them all up front, and you give them to me for a very steep discount. So it becomes cheap. Serverless doesn't do this. So what do quite some teams who jumping on serverless right now, they do a very similar thing what I described with the beginning of a cloud. They host the common environment on reserved instances using Dockerized environments and microservices. And combining this then with serverless functionality, there's also virtual, how it's called then? Servlets for Kubernetes, for example, which you can run in the cloud environment, to then put the peak into the serverless, which also has the advantage serverless spins up faster, where even a Docker instance maybe needs 30 to 60 seconds. Serverless, depending on what it is, probably takes 10 or less seconds. So you have a boost there too. But you combine them, and you address different concerns. Now I hope I made you a little bit hungry to think about where the boundaries of your application are. And because you didn't ask questions, I make you ask them now. Do you have questions? Really, the important part for decoupling is to understand what is your system boundaries. And we as developers always think in code, classes, or functions, classes, components, services. But you need to do, and that's why I brought the second part in, also to think about how it runs in production and what the implications are. Because only if you bring these two pieces together, you are successful running it in production where you earn the money. Right? Because that's where your company earns their money, by running the code, not by releasing the code. We can go deeper in dependency injection, but I try to make a very far-reaching talk to make you look into more and hopefully give you some starting points. Okay? Yes?
Since obviously you must have some background doing this, when it comes to Azure functions, is there any, since you're trying to keep the function very small, very specific,
Yes.
is there any reason to be using dependency injection at all in an Azure function?
And this is a tricky question, right? Because at some point, yeah, even in the function, you need to ask the question, where does the dependency come from? So yeah, you hit limits there. That's also, dependency injection is a great tool. Or it's a great tool in your toolbox to solve decoupling issues. But like every tool, not every problem is a nail, and not every solution is a hammer, right?
True.
So don't take one thing and apply globally. That's why my glue, or new is glue and never use glue, right, fell short. Because it would take the consideration that every problem is the same and everything applies equally everywhere. It doesn't. By the way, if you look into serverless in an elegant way, and I have not explored it more, I just recently learned a bit more about it, the virtual servlets for Kubernetes. Because in some regards, you can run something in the very same way, independent, because you're not hooked into the platform. So compared to Lambda or Microsoft Azure Functions, you're not, yes, you depend on Kubernetes, but you don't depend on the cloud provider, right? Because ideally, you want to be able, if needed, to move from one provider to the other one. And that's always one thing where you need to balance it and says, as more tightly I buy into the ecosystem of one provider, I get benefits, right? Things are more efficient, more tied together. At the same time, I'm more tightly coupled to that company, and if they raise the prices, if they do something else, I depend on that. So it's always also a business decision and consideration to say, how far do I go in a certain technology? How far do I specialize on a certain stack or platform, right? Microsoft doesn't mind to run your node code, right? And Google, I run the Bay.NET user group here in the area. We are hosted by Google, which is great. So they don't mind, right? What they really want is they want to host your production instances in their environment. That's where they make the money today. Yes?
So as we go to microservices, do you still see a lot of use of API containers, or I think small enough to don't bother you?
Was the question if I see still Docker or Docker?
No, I meant like things like, I don't know, Juice or whatever.
Yeah.
If you go to microservices, do you still do the whole constructor injection?
I would probably structure my code similar, but I may don't use the container because container have a load time, container have a resolution time. Then I need to take the use case and say, what do I win? What do I lose, right? Like everything. If I want to write the fastest scaling code and execution code, I probably don't do that, right? Because I buy the convenience of dependency injection or with automatic resolution or with the fact of delays in the execution. of resolving the code. In particular, if you think about microservices, which should be stateless, and ideally you bring them up, use them, you bring them down, that goes a little bit contrary to a container, where the container says, I bring it up and fast serve you with the dependencies, right? So this is where you get at a point where you say, probably don't want to use a dependency injection if this is a profile of my microservice. It's time to say thank you. First of all, thank you for coming. Please look for these gentlemen and ladies who make this happen, right? Amy, Peter, and the whole team who organized this. Think about, I didn't manage to take a picture this time, and the PayPal team and the volunteers. Without them, this would not happen, or it would be a lot more expensive. And the same applies to the sponsors, right? Without sponsors, such an event would also be much more expensive. Having this said, I will put this online, the slides, and if you have questions, please come by. If not, thank you so much for coming and enjoy your evening.